All right, everyone, we're going to go ahead and work on page 9. It looks like this. We're going to skip the first 3 for this video. I would like for you to do them anyway, but we're not going to cover it in this video. So what you're going to be doing is matching up these 3 statements to these 3 graphs. Now, one thing I'm going to be recommending we do, and I said this in the last video, is looking at what the axes are, the x-axis and the y-axis, because you could probably narrow down your search a little bit, because some of them, like if you were looking at them, you might look and say, oh, this one decreases, this one decreases, this one increases. Okay, that's great. But if you look here, this one says volume, where these 2 are dealing with temperature. So you might be able to narrow down your search quite a bit just from that. Okay, so let's go ahead and read through these, and then we're going to look at our, well, actually, we already looked at our axes. Notice that time is our x-axis on all 3 of them. That is also known as our independent variable, which I'm hoping you've heard from science class. Independent as in it's happening regardless, independent of anything, whereas our y-axis is known as our dependent variable, which is dependent upon, in this case, time. So the first one is heating water to the boiling point. We have cooling water to the freezing point. So both of these are talking about temperature. So I'm looking at these 2. Pulling the plug in the bathtub. So, okay, volume referring to usually water, like a liquid. It could possibly be referring to a gas, just kind of a space. So already, right off the bat, because I've narrowed it down and talked about volume, I know that B has to be with 3. And let's actually look at it. Pulling the plug in the bathtub, well, it starts out at no time. It starts out a high amount of water, and then it slowly decreases until we have no water left. So that does make sense in this scenario. Now we can take a look at these 2. So heating water to the boiling point. So when we heat water, the temperature increases. So here, okay, this one, it's actually increasing as time's going by. And then notice how it flattens out. It must reach, this would be referred to as its boiling point. Okay, so this whole portion is the water actually boiling. So we can say C would be number 1. And then 2 must be right here, A, because our water starts at a certain temperature, probably room temperature in both of these. And then it decreases, and then it hits that freezing point right here. All right. So again, that process that I just went through is something that, or the way that I want you guys to go about doing this. So for number 4, I would like you to actually try these on your own. So I want you to pause the video now, but then I'm going to also walk us through kind of the reasoning behind this one. So go ahead and pause it now. All right, we're back. So let's go ahead and read this problem. It says, Ben withdrew money from his bank account each week for 6 weeks. Then he deposited money into the account. Which graph best shows the story? Circle the letter of your answer. So this one is only one story. We're trying to figure out which one matches the best. So in all 3 of them, we have time as the x-axis, and then money in the bank for the y-axis. All right, so I'm going to read through again. Ben withdrew money from his bank account each week for 6 weeks. So I like to go ahead and put like a little slash showing me where there might be a change, right? Because each of these different angles represent a change in our story. All right, so first he withdrew money from his bank account. Withdraw meaning to take out. So that money he starts with having some money in his bank account, right? There's some money already there at 0 time. Here at 0 time, he's got no money in there, and here he's got no money, okay? So if it says he withdrew money, there must be some there already, and he's taking it out, okay? So here he is for 6 weeks. This is probably week 6. He's taken money out. Then he deposits or puts money back into his account. So here it is going back up, all right? So this one clearly is our answer, as it's the only one where he started with money to take out. All of these are implying that he put money in right off the bat. Okay, so that is the end for that one. All right, next we're going to go ahead and take a look at page 10. We're going to look at number 5. So this graph has already kind of started for us. It's showing time on the x-axis and distance from Talia's home on the y-axis. So notice that it says from her house. So if she's further from her house, that will go up. And if she comes closer to her house, it should come down. So it says Talia hiked 4 miles from her house and stopped to eat lunch. So I'm already going to go ahead and put a little line here to show that this is a stop in our, what's happening, which usually will represent an angle or change in our graph. Then she hiked back to where she started. Complete the graph. Okay, so that's already done and stopped. Now, and so it says show the distance from Talia's house to complete the graph. and then compare to the time that she took. Now, there is one thing. It says right here, she hiked 4 miles and stopped to eat lunch, and then she hiked it back to where she started. So there's actually something a little bit wrong here. That would kind of imply that it's just something like this, right? She just hiked, and then she came back home, because I only put one line here representing it. But I think there's an extra one kind of hidden here. So this implies that she went up and hiked there, and then just turned around and went home. However, we know that's not true. She also ate lunch, right? So it should probably be a little bit more like this if we use these lines to separate. Talia hiked 4 miles from her house and stopped to eat lunch. Okay, I'm going to go ahead and put one here too. So she hiked 4 miles from her house and then stopped to eat lunch. So now, here she went ahead. We got up to the 4 miles mark. Time is going by, so here we go. Then she stopped to eat lunch. Now she's not moving further from her house. She stopped, but time is still going by. So time is increasing. Give it a little bit of time. That seems pretty good. And then she hiked back to where she started. So once again, time is still going by. We should always be advancing to the right. So now she's going back closer to home. Her distance from home is decreasing, so it's going down. Okay, so we have a graph that looks something like this. So we went 4 miles. I'm going to go ahead and write it here just for, actually it's going to help us with the next problem, because it says use your graph to find the total number of miles Talia hiked. So this right here represents 4 miles. Okay. Here, during lunch, she wasn't moving at all, so that's 0. And then from her lunch spot back to home was another 4 miles. So it looks like she went 4 plus 0 plus 4 is 8 miles in total. All right, so it does really help to kind of put these lines in here to separate like the different segments of your graph, but then also importantly to look for times where you might be stopping, because that sometimes isn't a different sentence. Sometimes it's in the same one. All right, I am not going to do the final problem in this case. I know the number's a little weird here, but number 2 we're not going to do here. I want you guys to do that on your own. But we are going to take a quick look at number 1 and kind of talk about this one. So it says a ball is tossed into the air. Which graph best shows this? All right, so this one's a little bit funky, and I'm going to make an argument for neither of them really being perfect, but maybe one being better than the other. So when we notice how both of these, one says elevation, one says height. I would argue that both are the same thing. Elevation of the ball, height of the ball seems about the same, and time on our x-axis. So here, this is showing as if the ball is on the ground, like a height of 0 at first, when we first start. It gets thrown up, so time's going by, it's increasing in height. Then it's kind of levitating, right? It's time's still going by, and it's just sitting up there in the air. And then it goes down, and then lands, what I would say, on the ground again. So that one's a little bit funky. It kind of implies that the ball is just kind of levitating. I think it would probably, well, we'll talk about what I think it should be in a second. Here, it's starting at the very beginning. It's starting somewhere. So some people might argue that maybe it's starting at your hand, and then you throw it up. Okay, so here you're just holding it. You throw it up. So again, time's always increasing, but elevation is increasing here, so you threw it up. It does that kind of levitating thing again. Then falls down, maybe past your hand, but notice it never falls on the ground. So this is kind of a weird one. I would argue that this is not it. This would be something like you threw it from, you're holding it in your hand high up, threw it in the air, and then it landed on your hand lower. You caught it low, something like that. So it never actually reaches the ground. This one could maybe be if you were laying on the ground and threw it. But again, rather than it levitating here, I think it would be better off with a bit of a curve. Something like this would be a little bit more appropriate, I think. And even to make it even better, I'll show you what I think might be good. If you're throwing it, maybe it's here, you're holding it in your hand, you throw it up in the air, it comes back down, catch it again, and it's like that. Okay, so I would argue this is probably the best one, but again, that curve would definitely make it better, and then this would maybe make it even the best. So I want you guys to go ahead now, try number 2 on the bottom of page 10. Use our strategies of drawing lines, and take your time when you're looking between the different sentences and the graph, but then I also want you to go on to page 11 as well. Oh, one quick note. On page 11, this is not connected, it really should be. I want you guys to go ahead and connect it with a line like this. Okay, so there should be a line connecting that's kind of like angled a little bit to the right, not just directly up and down. So yeah, go ahead and work on those ones now.